Now, after understanding the different types of atomic radius, let us now do the trends of atomic size in the periodic table. Now, always remember, in a period, that means I am talking about horizontal rows from left to right. In a period, atomic size decreases gradually from left to right. So the atomic size, what we find, gradually decreases in a period from left to right. As we move from group 1 to group 17, what we find is continuously the size keep on decreasing. What is the reason of this decreases? The reason is pretty obvious. It happens because electrons are added to the same shell or orbit, but nuclear charge goes on increasing. This increase in the nuclear charge pull the valence electrons with the greater force. As a result, the size continuously keep on decreasing. I can explain you this with an example of the elements of the second period. If we take elements of second period, like we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, what we find is their atomic number are 3, 4, 5, 6, 7, 8 and 9. So what we find is, since they all are belonging to the second period, that means their valence electrons are entering into what? The second orbit. So all of these are only having 2 orbits. In the atoms of all these elements, we have only 2 orbits. Now, total number of electrons in this case of lithium are 3, atomic number is 3, and nuclear pull is +3. So +3 is pulling these 3 electrons, definitely it's fine. But as we keep on increasing, like in case of boron, again there are only 2 orbits, of course, around the nucleus, but electrons are how many? They are 5. So nuclear pull is +5. As we are into the fluorine, we know what is there is, again the atom has only what? 2 orbits, but electrons are how many? 9. So it's already it is having 7 outside in the second orbit. So these are the 7 one, and the nuclear pull is +9. So now you can easily make out this nucleus with the +9 positive pull will pull these electrons towards inside with a much greater force. As a result, the size shrinks, and what we find is the size gradually decreases as we are moving from left to right in the periodic table in the period. There are, of course, what we find certain behaviors which are not changes which are not aligned or which are not according to this behavior. The small change which we find in this is in this value of nitrogen. What we find is nitrogen's size, the difference, of course, if we have to arrange it like this, I can tell you the lithium is the largest, then we have beryllium, then we have boron, then we have carbon, then we have nitrogen, then we have oxygen, and then we have fluorine. So there is no point in this. Of course, nitrogen is smaller than carbon, it is bigger than nitrogen, but the difference, yes, which we can have between these two is not like the usual one. Nitrogen is slightly bigger than the expected value. The reason is it has half-filled 2p3 configuration. As a result, these 3 electrons have what? More inter-electronic repulsions, so therefore they require a little bit larger size. Now let us study the trend of atomic size in a group. Now in a group, that means in the vertical columns from top to bottom, what we find is atomic size decreases, it's not decreases, atomic size increases from top to bottom in a group. So as we move from top to bottom in a group, what we find is always the atomic size increases. Except only one exception, we always find that it is always increasing in a group down the group from top to bottom. The reason is because new orbits or shells are added with each period. So what happens is, therefore, addition of new orbits dominates over the increase in the nuclear charge, and that's why what we find is the atomic size increases. Let us take this with an example of group 1 elements, alkalis. And in lithium, sodium, potassium, rubidium, cesium and francium, what we find is this lithium belongs to the second period, this is from third period, fourth period, fifth period, sixth period and seventh period. So what we find is, as we move down the group, new shells or orbits are added, so automatically the outermost electrons, the valence electrons are moving away from the nucleus, the size increases as expected. But simultaneously what we find is the nuclear charge also increases. Like in case of lithium it is only 3, but in case of sodium it is 11. In case of potassium it is 19. We know as the nuclear charge increases, definitely the pull on the electrons will get increased, so they will come more closer to the nucleus and it will shrink. But what happens is, it is the screening effect, shielding or screening by the inner electron, which prevents this, and what we find is actually the size increases down the group. We have only one exception to this. The exception is in case of group 13, boron, aluminium, gallium, indium and thallium. What we find is that this boron is from the second period, this is from the third period, fourth period, fifth period and sixth period. The gallium is having atomic number 31 and it comes after zinc the moment the 3D gets completely filled. Now D are inner n-1 subshells. The moment the electron goes into the 4p, that is in case of gallium, what we find is it gets poorly screened by the inner electrons. Due to poor screening, what we find is the atomic size of gallium becomes smaller than aluminium. So that's the exception we have, that the radius of gallium is smaller than the radius of aluminium, which is just the reverse of the trend which we usually have. So this happens because of poor screening of the gallium valence electrons by the inner electrons.